Alright, my name is Jacques Boudreau, and today we're going to talk about how to measure the rotational velocity of an object by using a wheatstone bridge and an oscilloscope. So this right here is the oscilloscope. This is my circuit setup, and just to compare with the wheatstone bridge, so R2, R1, and R3 can be represented by these three resistors right here on the circuit. This voltage output right here is represented by this red wire right here and this black wire. You can see them connected right there. I'm getting power supplied to the breadboard right here. And these two green wires right here represent this R4 right here, which is going to be my variable resistor. And to make it variable, what we're using is this photoresistor right here. You want to zoom in? And so this photoresistor is going to be able to measure changes in light, which is going to change the value of the frequency and give us a reading. So what we're going to do to measure the rotational velocity, so right here what I have is a Hamilton Beach egg beater. They have two outputs, but in order to measure, we're just going to use one. And the light that we're going to use to adjust the resistance of the photoresistor, just this cheap flashlight I bought from Walmart. And it would be better to use a laser. And so to try to simulate the effects of a laser, what I did was I cut a small hole out of the flashlight like that. And so it was actually like the perfect size. And so it fits pretty snugly into this right here. And so it doesn't allow too much movement. Alrighty, so I just powered up the oscilloscope, and now that we got that running, we're gonna come over here and I'm gonna adjust this light to where whenever it rotates, it's gonna pass in front of the photoresistor and it's gonna give us a change in frequency. So what I'm gonna do is I'm gonna start it up, I'm gonna let y'all look at it, what it's doing for about 10 seconds, then we'll move on to the oscilloscope and I'll show you the reading. And so if you look at the measurement that was done by the oscilloscope, you'll see that every time the light rotated, it had approximately a constant velocity, so you can see that the graph is proportional. And so the sensor is doing pretty good. But you'll see right here, it recorded a frequency of about 10 hertz. The oscilloscope, it read it to be about 10 and a half hertz of frequency. And the way that you convert this frequency into the RPMs is like 1 hertz is basically about 60 RPMs. And so we were at about 10 hertz, so that's approximately 600 RPMs. And actually that's not that accurate of a reading. That could be due to the sampling size of the oscilloscope that we're using, or a couple other factors, but the max speed, the RPMs that this object is rated for on the high end is about 300 RPMs, and so I think that it could have to do with the sampling rate and the high velocity of this, and just the cheapness of the sensor not being able to pick up the frequencies as good as it could. So in conclusion, that's how you use a photoresistor to measure the angular velocity of an object using a light, a wheatstone bridge, and an oscilloscope.